panel is composed of 3 IC managed customers. Next up, we're going to have Vincent Ross, who is the CAD architect at AMD. Vincent has held several positions with AMD at AMD and ATI Technologies. He was technical engineer in ASIC design, verification, and IP modeling, specializing in custom analog and IP models. He was also a manager in the hardware modeling organization, doing standard cell design. Please come on down.
So the top 2 challenges addressed by AMD design management systems. Essentially, supporting multiple parallel product tapeouts and IP reuse. So AMD does many parallel ASICs, taping out at multiple sites throughout the world, and making sure that we have the right version of IP going on the right version of the parallel products, all in tapeout, are incredibly important. We effectively need to do this to minimize cost. Also, alignment of these multi-site teams. It's quite easy to get unsynchronized when you've got a very diverse engineering organization. So getting clarity on things like the design requirements, the ability to change the design requirements and stay synchronized across all those design sites, being able to make sure that we have consistent design against the right version of the technology inputs, making sure that all of the various sites and design organizations are handing off their deliverables to the same associated sets and quality standards, and ensuring that the correct version of sanity checkpoints are being run at the correct points in the design cycle, and having the ability of a design system to effectively take learning from history and upgrade the overall system. In terms of best practices from a design and IP management system, essentially specification-driven IP design, change control, and that sort of thing. We need to ensure that we have the correct views ready for handoff, including all of the nitty-gritty things like the appropriate PVT lists, etc., that a given SoC product would need. Leveraging revision control. So there's really 2 levels of revision control that we need to worry about. One is what I call coarse grain. Essentially, the handoff of large IP blocks to the various SoCs and making sure that the correct version of an IP block makes it to tape out. There's also a finer grain characteristic, one that is more in tune with the development of the sub-IP itself, enabling things like schematic and layout to be co-designed at different design sites, being able to bring in contractors, leveraging all of those coordination issues, really needs a very good and robust fine-grain schematic and layout revision control type of system. So AMD, as an example of this, is leveraging IC Manage for that definitely this aspect of that workflow. Quick rework turnaround times. So we need the ability to be able to react to unforeseen changes. Whether it be changes in the technology very close to tape out, or feedback from the SoC integration organizations that needs to be reworked into the sub-IP before getting ready for the final push. So in terms of must-haves, we talked quite a bit internally about this, but one of the big challenges we see is U.S. export control. That has turned out to be an incredibly important thing to get a handle around. So having the design systems be compliant to the regulatory restrictions, having that percolate across the multiple design databases and correct controls, as per what Doug was alluding to. You basically only if you need to know the design data to work with it should you be having access to that data. Efficient large data set synchronization across sites. Transfer speeds, smart caches, all are needed to ensure that you've got multi-site design organizations are enabled and that their costs are controlled. Another aspect is waiver enablement and control. So to a larger degree, this talks to agility. There are occasions when waivers are needed to ensure that the right engineering and management judgments can be put into place to ensure that the tapeouts can still be achieved on time, very close to tapeout. Integration of test regression and connectivity to the design management databases. Ability to see percentage of test coverage, various aspects of IP status are also important to understand through the various phases of the ASIC development, especially for management. So some of the outcomes of implementing some of the best practices and must-haves, effectively enabling for AMD to be able to tape out multiple parallel products per year and per business unit. So we have the challenge of IPs going into many possible parallel ASICs. That all has to be tracked and understood the correct versioning, as well as tapeout organizations all pushing for that work in parallel, means that it's very easy to get defocused on any one specific IP. Enabling a worldwide engineering organization. So again, making sure that everyone is aligned to the definitions and the proper frameworks is incredibly important just to minimize mishaps. And the ability, as I said, to react quickly to unforeseen conditions, including late fab tech files and whatnot. Okay. In terms of, I guess, quantification, we have a very hard time clearly defining the quantifiable benefit from a specific design management implementation, primarily because the ASIC complexity is growing every single year, as well as the complexity of the foundry technologies that we happen to be using. So the best way of saying it is the capability to still tape out these very large and ambitious products is a testament to the design management system in itself.
Thank you.